Welcome back, ladies and gentlemen. I'm your host, Kev Baker, and welcome to another live broadcast of the Kev Baker Show right here on Truth Frequency Radio, and that is www.tfrlive.com. Now, we're going around the world on various platforms, various ways to listen. I would love you to come right here to the home of KBS at tfrlive.com, or you may have iHeartRadio, TuneIn Radio apps, various ways to listen. Visit the website, the homepage at tfrlive.com to find out more. And we've got our very own chat room over here at TFR Live, and I'll give a quick shout out to everyone over there. All you have to do is go to tfrlive.com/chat. And we are getting into my favourite topics today. We are going full science. And before we came on air, I personally thanked today's guest because I believe that he has raised the caliber of information that we're being exposed to right here on my show. And not only that, but the stuff that myself and today's guest gets into, it's not the typical fare that you will hear on your alternative media show. And what I mean by that is, a lot of the time, myself included, we spend hours speculating and talking about things that we see in the news that we might not quite know enough about to be saying some of the things that we say. And I'm not casting anything at anyone out there. I'm talking about myself first and foremost, and so many other shows across this alternative media world that we're in. You know, going to the real scientists and talking real science isn't too popular with a lot of people. However, if we are true to our word and we're here to learn and we're here to grow, then I think it's important that we listen to all sides of every debate. And how can we possibly act like experts in a field such as science when most of us, and again I'll speak about myself here, have never really had any education above and beyond what I got in school? So that's why I really thank today's guest. And we'll get to him in just a moment because, you know, this world that we're in right now, maybe not enough of us take time out to show our appreciation to people. Yeah, we react on social media. We have that knee-jerk gut reactions. And it's so easy for us to cast insults and shout at people and be derogatory to one another just because somebody holds a different belief or a different mindset. Yet when you look through social media, you don't see too many pleasantries the other way. Thanking people for having a different point of view. Thanking people for bringing information that helps all of us grow and form that bigger picture. So I'm really looking forward to getting into today's show. But before I get there, I've got another quick science update. Now, one of my proudest moments on KBS to date, and probably forever, will be speaking to the man that founded D-Wave Systems, and currently at Sanctuary AI, Mr. Geordie Rose. And on one of my recent streams, I had a bit of a crisis occur because I went to show people all of Geordie's really cool robots over at Sanctuary AI. But something went wrong. The website has gone back to being private. There's a password-protected landing screen. Even the Twitter feed has had its account cancelled. And we were all left to speculate as to what may be going on. And I said at the time I would reach out to the man himself to try and find out just what was occurring. And it's taken some time, but I promised you I'd get the truth, didn't I? And Geordie got back in touch with me today. And he says, you know, Kev, everything's fine at Sanctuary. It's just maybe they decided to go way too early for that public kind of presence on the internet. He doesn't want to under-promise and over-deliver all of this stuff. So there's still a lot of work to do when it comes to the AI at Sanctuary. So if you see anyone out there coming up with any ridiculous conspiracy theories, you know, maybe the robots have taken over, you know, maybe the AI has gone rogue, it might not be as exciting, but that's the truth, folks. And I thank Geordie for getting back in touch with me to clear that up. And I hope that clears it up for everyone out there as well. So then, let's get back into today's show, right? Because I have got an equally cool scientist here with me. and I'm joined by a good friend. I haven't met him physically, obviously. We're on other sides of the pond, but I really do like this guy. I respect what he does, and I absolutely love listening to when he talks because he's really, really clever. His name's Brendan Drachler, and he's an astrophysicist from the Rochester Institute of Technology, working to understand how we can detect the most dense and energetic objects in our universe, black holes and neutron stars. Now, he's also working to understand the fundamental structure of black holes and just how we can learn more about them. Brendan has spoken on topics ranging from our solar system to the nature of dark energy, supernova, and many things in between. Right here on this show, we've covered big data, 5G, and today we're going to be getting into something that I know is going to be controversial. We're going to be talking climate change and climate science. Now, for more about Brendan, you can head on over to thestateoftheuniverse.com. That's thestateoftheuniverse, one word.com. You can also check out his top 10 downloaded from the science section on iTunes podcast by the same name, The State of the Universe, where he is lucky enough to talk to some of the world's leading, and I really mean this, folks, the world's leading scientists. And he's here with us today on KBS. Brendan, my good man, welcome back, sir. How you doing?
I'm great, Kev. Thanks for the introduction.
Dude, it's like I said
you
to you.
throw compliments at me. I don't know how to take them. I don't know what to do. I love it. But I'll say this. You said something in your introduction that's interesting. You said it's not popular for people to sit down and talk to actual scientists. Well, I'll tell you this about scientists, and something I find. It's not popular for them to be willing to sit down and talk.
Very good point, sir. Very good point.
So I noticed that, like, you know how many emails I send that go unresponded to? Dozens, and people don't want to talk about the work they do. And I think that's a big problem. It's a huge problem. And it is the reason that some people deny aspects of science, because you have people who all they want to do is sit in a lab and tinker all day and never communicate what they're actually doing. And I'm glad to be here doing just that.
Well, it's like I said, Brendan, because of that very reason, sometimes people like myself, the listeners out there, all we're left with is a gap in the information. We get told certain things in the media, but not by the scientists themselves, and from there, we're left to speculate. And that's why sometimes I think some of the more wild ideas emerge onto the internet. So that's why I took the time to thank you on and off air, because like I say, you've really helped me personally look at things differently. Maybe we still don't agree on everything, but that's okay, Brendan, because, this is what it's all about, having a conversation. And I think for the audience out there, I think they're all learning and growing from these shows as well. Again, maybe not all agreeing, but at least they've got that information there to go against everything else that they've been hearing, that they've been putting together themselves as well. So again, thank you. And today, we're getting into something completely different, which is something I also like about you. Yeah, you do astrophysics. You're working tirelessly on this simulation with two black holes colliding, which I don't know how there's enough hours in the day for you to do what you do, Brendan.
There's not. That's the problem.
I know, right? And now, today we're going to get into something totally different again, but something that does affect us all, because we all share this one planet, and we're going to be talking about climate change. Now, I remember when I left school back in the 90s, we were getting told that literally by this year, I would imagine when I left school, I would have thought coming towards 2020, living in Glasgow, which isn't a million miles away from the coast in Scotland, that we would be underwater by now. Now, thankfully, that hasn't come to fruition. But I want to get all the latest from you. What you think about the climate change? What is climate science? What's all the fuss about? Should there be a fuss? We can touch on the Amazon, the fire that's going on. There are so many ways we can take this. But climate change, should we be scared, Brendan?
Should you be scared? I'll tell you, you shouldn't be as scared as maybe you were convinced you should be when you were in school, like you were just talking about. You shouldn't be so scared that Scotland is going to be underwater. Say there are two camps in, I'll say, the politicization
That's a
of
word
climate
and a half.
change.
Okay? Don't try
That's
and say
quite the
that
word.
after a couple of whiskeys.
There, there are two camps, and they both equally suck. One camp is completely denying the existence of any changes with the Earth's climate, and the other camp is pretending that the Earth is going to die in 12 years if we don't act. Okay, both of those are, in my mind, equally nonsensical ideas. But we can jump into them. I'd be happy to. So, should you be worried about climate change? You shouldn't be worried that you're gonna die. But you should be worried that humans have a pollution problem. That's how I always like to phrase it, right? Because one of the problems that I have with like the way that politicians tend to attack climate change is they ignore that there are some pretty big problems that you could call ecosystem change as well, which are like human beings dumping, thousands of tons of garbage into the ocean. Do you know what the Great Pacific Garbage Patch is? Have you ever heard of this?
Oh, unfortunately, I do know what that is,
Yeah,
yes.
and there's one in the Atlantic, and there's one in the Indian Ocean, and there's one in the South Pacific. In any gyre, there is a gyre is like an area where the ocean current tends to pull stuff. They tend to be right in the middle of continents. These currents circle and circle, and all of the trash gets like whirlpooled into one location, which is actually a good thing for us as a side note because it makes cleaning it up kind of easy. Now, it's not easy, of course, because the Great Pacific Garbage Patch is like 3 times the size of France. So, of course, it's not easy to clean all that shit up, but it is easy to locate it because it does tend to cluster in very nice areas. So we could feasibly if we wanted to. So that's why I always talk about we have a pollution problem and we need to do a better job of it. Is the pollution going to kill you tomorrow or in 12 years? Probably not, but that doesn't mean you shouldn't try to address it or solve it in some way. But it's interesting to me that climate denial exists on the level it does. I mean, even in the United States, only 30% of people in surveys will agree that climate change is happening and it's caused by human beings. Meanwhile, in the scientific community, you always hear the 97% number. 97% of climate scientists agree. The actual number is probably, a little higher than that, maybe approaching 98. And then, of course, what they don't tell you in those surveys is that there are some people who answer the question, I'm not sure, because they don't like the way the question is phrased. The question is normally phrased, are humans causing the changing climate? That's a tough yes or no question. Like some scientists don't want to put a yes or no on that. They want to say, wait a minute, there's a lot of technicalities in there. Let's talk about the technicalities. So they tend to say, I don't know. And so that brings the number of climate scientists that say no only to like 0.5%. And we could talk about
I'm a pseudo. I'm
Yeah.
probably what you'd class as a pseudoscientist, right? But we'll have a laugh with it. Kev, the pseudoscientist, you, the
Yeah.
astrophysicist, and sometimes I've stated that, and this is just my idea because I don't know, Brendan. Okay, but I've always kind of told people that when it comes to the climate, it's always been changing. Okay, I mean, from the dawn of the planet, from the dawn of time, climate changes.
Exactly.
That happens, and for me, I look at the biggest driver of that, not to say we don't contribute to it, but wouldn't the sun and the way the sun's acting being one of the main drivers as well? Or am I totally wrong there?
Well, what do you mean by the way the sun is acting? The sun is essentially, outside of large solar storms that throw energetic particles our way, the sun is essentially outputting the same amount of energy on the Earth, regardless of year or day or time period, and that won't necessarily change until a couple billion years go by.
Well, see, that's what I need you to tell me. You see, that this is why I was saying in the introduction that people like myself, we sometimes talk about things that we truly don't know about. Sounds really quite logical, the sun drives the climate, but in reality, what you're telling me here is, and it makes very good practical sense, that the sun always is outputting a steady energy. So in reality, it's always been outputting the same thing. So not really too influential then when it comes to climate change.
There are differences in the amount of energy that the sun outputs, measurable differences, in fact. But at 93 million miles, the amount of energy that is radiating onto the tiny little blob that we call home is not necessarily changing a meaningful amount enough to to impact the large scale climate of the Earth. Now, we do know that there have been cases in the history of the Earth where there's been perturbations in the orbit of the Earth that has caused it to inch closer. Inch obviously is a bad word for this, but when I say inch, I mean, tens of thousands potentially of miles closer to the sun and further away from the sun in its orbit, and those have caused some large scale climate change type effects. But we're confident that that's not necessarily but Kev, before we even talk about climate science, I always like to do this. Okay, listen, politics play a role in climate change in a very interesting way. It's like one of the few scientific ideas that have become a political issue, and it has everything to do with the fact that these people on the left, I would consider myself politically conservative in most regards, and a lot of the people on the left that you see, specifically in American politics, I can't speak for politics in different parts of the world, but in American politics, like, you latch on to this climate idea, and then they try to tack a bunch of extra stuff onto it. Like the Green New Deal in America is a great example of that, right? They're like, listen, we got to fix the climate in 12 years, but also we have to give free money to everyone. We have to open the borders, and we have to do X, Y, Z, down the line. And I think that breeds a lot of people who are like, I don't want to find common ground with you. And my way of not finding common ground with you is by denying the thing that you're latching onto, which is climate science.
So do they basically use something like climate science as a vehicle to hitch other agendas onto then?
Of course.
Yeah, there you go.
Of course. Yes. That's what every politician is good at, right? They're good at finding a problem in the world and saying, okay, I know how to solve the problem. The way to solve the problem is the direct solution and the 77 indirect solutions that are me just getting the thing done that I want to get done, right? And unfortunately, climate science is right now the talking point of the political left, and at least in America it is. And so they latch onto it, and they almost corrupt it. Not in the sense that scientists are corrupted, but in the sense that people don't want to align themselves with, people like AOC or the people who pioneered the Green New Deal. There's a lot of people who are like, whoa, we are not democratic socialists. And if democratic socialism means believing in climate change, then I'm going to distance myself. I think I see a lot of that occurring.
Now, Brendan, I have to warn you, I am a big fan of AOC, not her politics, just on an aesthetic level. I think she's a wonderful lady. Some of her ideas, well, she's even more pseudoscientist than I am. But let me give you
I like aspects of her too.
Let me give you another one then, because this is a name that always comes up when you talk science, rightly or wrongly. Al Gore. Now, Al Gore back in the day would have us all believe that if we paid him enough carbon tax, everything would be cool. We would all be singing Kumbaya, and climate change wouldn't be a problem. Now, he had his film, The Inconvenient Truth, or as I call it, The Convenient Lie. Mm-hmm. And when that came out over in the UK, I'm not sure if you're too aware of this, but there was so much, well, we'll stick with pseudoscience in it, that what happened was, after it had been initially introduced into the education system, where children were basically forced to watch this, what happened was they pulled it, and they wrote a 72-page kind of addendum that goes along with that documentary, and I believe now it's something that they don't subject children to. So Al Gore, carbon taxes, is that going to fix the world?
I don't think Al Gore is going to fix anything.
No.
We'll say that quick. But yeah, I mean, clearly he made a lot of money off of that, right? Yeah. That was as much a economic ploy as it was anything else. And that's very clear. And isn't there like a sequel to that coming out?
Probably did.
What is the sequel? The world didn't end, so here, give me more money now for the next 12 years? I don't know.
Sorry, he'll fly around the world in his carbon-heavy private jet telling people all about it.
Yes, of course, naturally. What was the second part of your question now? Will carbon tax fix it? I think economics will play a role in fixing it. Unfortunately, though, renewable energy just doesn't make financial sense yet. And people like to say, oh, it's due to lack of subsidies, it's due to lack of this, it's due to lack. But America is heavily subsidizing renewable energy. I mean, heavily is subsidizing it. They're also still heavily subsidizing fossil fuel companies, which is insane to me. That for some reason you feel the need to subsidize billion-dollar organizations, but almost trillion-dollar organizations at this point. But we need to find a feasible way to make cleaner energy better. But that's an interesting point too, because what the hell does clean energy mean? I mean, when you're talking about like self-driving cars, battery-powered cars, they have to mine the cobalt from somewhere, right? And the lithium from somewhere, and those mines are incredibly destructive to the regions that they mine from. The same thing happens in like the vegan community. It's like, what is the good alternative here? Because they talk about not wanting to eat cows because they produce methane. Meanwhile, they are directly supporting soy farms that burn down the Amazon rainforest. So that's why I always address this as a pollution problem. Like, we need to just be better about the way that we treat the planet. We don't need to like get rid of fossil fuels. We don't need to stop eating meat tomorrow. We don't need to do all these crazy things. We need to be better about the way we treat the planet. That's the way I always try to phrase the question. And also, Kev, do you know how we're talking about this right now? In a very nice way, civil way. That is because we find common ground in certain things, and we're willing to sit here and chat and decide what we do and don't agree on, and then break down those barriers and talk about them. But when you're not willing to do that, when you're just yelling at someone and telling them they're stupid, they're not going to listen to you. And in fact, they're going to it's a very popular thing in the world of sociology. It's called the backfire effect. And when you treat people that way, they tend to go further towards the side that you want them to go away from. So if I come to you, Kevin, I'm like, you're so stupid. You don't believe humans are hurting the environment. Why? How can you be so dumb? Like, are you this dumb? If I did that to you, you probably would have already kicked me off the show, rightfully so.
I probably wouldn't have, we'd probably still have fun.
Yeah, that's true. That's true. But if I did that the first time I ever came on the show, that would be a problem, right?
Yeah,
it's
very
different now.
Very counterproductive, dude. Very.
Yes, of course it is, and everyone knows this. Yet everyone still tries to communicate like that, and it just polarizes everything more in the climate world. But we can start getting into the particulars of climate if you'd like.
Because I was going to say to you, over here in Scotland, people talk about UFOs, but in Scotland, the UFO typically could be the sun, because we rarely see it, right? But
Sure.
But in recent years, I mean, last year, it was almost like I was living in Spain or somewhere tropical. This year, we had a pretty good summer, not as bad as last year, but across Europe, we've seen record high temperatures. Down in the south coast of England as well, France, Spain. It's been absolutely baking. Now, that's one summer, but does that indicate a change in the climate, the raising temperatures during the summer, things like that?
If it's a trend, yes, which it tends to be. If it was just one summer, if it was just this summer, I would say no, you can't draw a conclusion off of that. But it is a trend. Donald Trump is a fan of doing this, of taking a very cold day in the winter and using it as evidence that climate change isn't happening. And he's wrong for doing that, and he's incorrect in doing that. And in the exact same way, just because it was hot for this summer in Europe does not necessarily mean that those temperatures were caused by climate change. They could have happened in a perfect utopia where all we did was use renewable energy. You're still going to get natural variations in the temperature in any given year. That's going to happen. But what's a good measure? A bad measure is the temperature in a specific location. A good measure is the temperature of the globe. And that's what we're talking about when we say that the temperatures are rising. Is we're talking about the temperature of the planet itself. We're not talking about the temperature of France, or even though those were incredibly high and abnormal, or the temperature in Alaska, even though those set record high temperatures in Alaska. July 2019 was the hottest month that we had ever recorded in human history. So yes, this was an abnormally hot year. Now we'll find out in the next 5 years if that's a trend, if it continues that way, and it probably will. And the reason it will is because the global temperature has risen. The global temperature has risen 1.6 degrees above whatever value it was in 1850, which was like 57 degrees Fahrenheit or something like that. But the global temperature is a way better measure. And the global temperature is increasing. And the part that's really problematic, Kev, isn't even that the global temperature is increasing. It's that the temperature in the Arctic Circle is increasing at a factor of 2 or 3 times the global temperature. So the Greenland ice sheet is literally melting billions of tons of ice per year into the ocean.
Now, we're almost on the break, and I want to remind people you can follow Brendan over on Twitter at Brendan Drachler. Visit his website, www.thestateoftheuniverse.com. We'll be right back. Welcome back, ladies and gentlemen. You're tuned into today's Kev Baker Show, coming to you live from Glasgow, Scotland, right here on Truth Frequency Radio. I've got Brendan Drachler, an astrophysicist from the Rochester Institute of Technology, with me. Visit his website, www.thestateoftheuniverse.com. That's thestateoftheuniverse, one word, .com. He's on Twitter at Brendan Drachler. You can subscribe to his podcast by the same name, The State of the Universe, over on iTunes. Last time he was telling me it was in the top 10 science podcast downloads. That's no mean feat, ladies and gentlemen. And that's because what Brendan talks about, he's quite popular because people like to listen to what he's got to say and the guests that he brings on as well. So give him a follow over on Twitter. Keep up to date with everything that Brendan's doing. And before the break, we were getting into climate change, climate science. And Brendan, you threw out something in global temperature. Now, how on earth's name do you work out global temperature? I mean, do you just look at the weather forecasts and take an average out of all of those? How do they do it?
It's an excellent question. And the analogy I always like to use. Yeah, and this is a great question too, Kev, because here's the thing that climate people who educate others on climate tend to do is they tend to just be like 97% of scientists agree it's happening. But I think it's better to actually go through the scientific method with people and explain how we come to the conclusions we come to. And so global temperature is measured very logically, in fact. Kev, if you wanted to measure the temperature in your house, what would you do?
I'd use a thermometer.
You would go to the thermostat, I presume, right?
Yeah, exactly, yeah.
Okay.
We don't have we're kind of living in caves over here, Brendan. So we've got no, we've got thermostats.
You're a smart city. You should have a thermostat that knows when you're too cold.
Yes,
too hot.
We're getting our smart meter in this year. Don't talk to me about that. That's another show altogether, dude. Okay, but yeah, thermostat then. Okay.
But anyway, if you want to know the temperature, you go to the thermostat. Now as well as I know, especially living in an apartment building, I do right now, that the thermostat tends to be wrong. And it's not wrong because it reads the wrong number, but it only reads the number in a very particular part of your apartment, right? So it could be really cold by the window or really hot in the bathroom, but the thermostat tells you it's a nice 66 degrees or something like that. I mean, I'm sure you experience this, Kev.
Well, all the time. I've got drafts coming in the window. One room is never the same temperature as any other room. So yeah, I totally appreciate that.
Yes. So the way in which you would get the real temperature of your house is not to go to the thermostat. That's probably a bad way, in fact, to get the temperature of your house. It's only a good way to get the temperature of that very particular location. A better way would be to take a thermometer and go to every square foot of your house and try to measure the temperature. And then you could say, okay, well, the temperature in the bedroom is 67. The temperature in the kitchen is 72. By the window, it's lower. In the bathroom, it's higher. And go to every square foot or every square meter and try to measure the temperature everywhere. And then you could have an entire idea of what an average temperature of the entire house is. Well, on the Earth, we literally do the same thing. We do the same thing. We have, and admittedly, it's a hard thing to do because you have to go to every little place. Well, the NASA, I know people hate NASA, so the National Oceanic Atmospheric, I don't know, NOAA, whatever that stands for.
Yeah, NOAA,
yeah. You know them, but whatever the acronym is. They do this. You have the UK does this. Japan does this. Very many countries do this. Also, private organizations do this. If you don't trust countries, universities try to do this. The best ones that exist today have about 7,000 nodes, and what they are is literally little thermometers that they try to put evenly spaced throughout the entire globe, all over as many places as possible. So that they can measure an average temperature. They put them in the water to measure the water temperature, sometimes in the air to measure the air temperature. etc., and to try to come up with an average temperature for the entirety of the globe. And in fact, if you look, this is a really impressive information about climate science. I think, Kev, could we find common ground in agreeing that this is a good way to measure temperature? I mean, could you come up with a different way to measure the temperature of the Earth?
No, I think if you've got like equally kind of spaced thermometers, measuring gauges all around the planet, then I think that would give you a pretty good idea. Once you pull them all in and work your average out, I think that would be a good way of doing it.
Right. That's a good way to do it. I would agree that's a good way to do it. A better way to do it would be to install 1 million of them, right? Instead of having them sparsed maybe every mile or 2 miles or 10 miles apart, have them like literally every, 100. God, I always speak in miles and feet. Is that annoying to you, Kev?
I do. No, the UK, this is the weird thing, right? Europe are kilometers, but in the UK, we're very much miles and feet.
Oh, are you? Okay.
Yeah,
well, that's nice.
Yeah.
That's nice. So, if we could put one every 1 foot, every square foot, that would be great. And we would get much more accurate numbers. But we space them out as we do, and other organizations do the same thing, and they put them all over the globe. And we are in astonishingly good agreement about the temperature of the Earth. All of these different data sets collected by different people at different times in different places, but using the same idea, all have astonishing agreement on the temperature of the Earth, the average temperature of the Earth. So that's how we go about actually measuring the temperature of the planet. And in fact, it's a pretty stable temperature, which should surprise you. But at the same time, it shouldn't surprise you. It should surprise you that something so large and chaotic and in the universe could be the same temperature. But if you study thermodynamics, then you should realize, wait a minute, the Earth isn't producing any energy, right? There's no like nuclear fusion happening in its core. And so it's kind of just a rock sitting in space. And we know the temperature of rocks sitting in space. In fact, if you ever take a thermodynamics course in college, or you ever take, like a radiation course in college, that's one of the first calculations you'll ever do is you'll calculate the temperature of a planet sitting at a distance from a star. It's a very easy calculation to do. It's a very, accepted calculation. And it's one of the first things you do. And so when you study that, you realize, oh, wait a minute, it shouldn't be any surprise to you that this rock actually stays the same temperature. It should be pretty stable. But there is something that changes the temperature, and that's when we get into greenhouse gases.
Ah, yes, the greenhouse gases. Everyone's heard that term, greenhouse gases, but like I was saying to you during the break, showing my age again, right? I remember when they were going on about fridge doors, the old aerosols that we used to use, and this thing called CFCs.
Mm-hmm.
Now, again, I'm somebody that's bandied this term, greenhouse gases, about, but if somebody had sit me down and grilled me, Kev, what are these greenhouse gases and why are they important? I would have had that stupid dumb look on my face. So, what are greenhouse gases?
Well, I'll ask you, Kev, do you actually know if greenhouse gases are important? If I just say if they are important.
I just assume they are because we've been told so often that the greenhouse gases and everything related to climate change, it's all going to be scary down the road and we're headed for doom and things like that.
Yes.
So, no, to be honest with you, no.
Okay, so even in the absence of let's pretend climate change doesn't even exist. And let's just talk about greenhouse gases. We rely on them. In fact, we need them. We need water vapor in the atmosphere and carbon dioxide in the atmosphere and methane in the atmosphere. It is important, or we would not be here. And the reason it is important is because of the function they play, the role that they play in keeping us alive. If we had no atmosphere, the situation I just talked about, that easy calculation I talked about, if you do that as an undergraduate student in physics or astronomy, you would calculate the temperature on the Earth and you would come up with a weird number. It would be 0 degrees Fahrenheit, like negative 18 Celsius or whatever that would be in Celsius. And you'd say, wait a minute, the Earth's average temperature isn't negative 18 degrees Celsius. That doesn't make much sense. And you scratch your head for a little, and then you realize, oh, wait, we have an atmosphere. The atmosphere plays an important role. What happens with the atmosphere is you have this ultraviolet light streaming in from the sun, and it streams through our atmosphere and it hits the Earth and it heats stuff up, which is why if you stand outside in the sun, you get heated up. You wouldn't know that, of course, but if you go somewhere beautiful, which has sunshine, you would know that if you stand outside, you get heated up from the sun. Your houses get heated up, your cars get heated up. It's super hot in my apartment right now, thanks to the sun heating everything up. Um, it heats everything up, but it doesn't just heat stuff up because the stuff that gets heated up also radiates photons back. If you look at human beings in the infrared, if you have an infrared camera, you would see us glowing, like glowing incredibly brightly. And that's because we are objects with heat. We have heat inside of our bodies. And because we have heat, we have thermal energy. And because we have thermal energy, we radiate photons, infrared photons, all the time, every day. Wherever we're walking, we're just radiating photons off into the sky. And we're not the only ones that do it. Houses do it, cars do it, streets do it, trees do it, everything does it. They stream photons back up, and this is the important. This is where the greenhouse gases come in. This is very important. The reason the Earth is a higher temperature is because when those photons go back up, they try to escape the atmosphere, but they have much less energy than they did when they came streaming in. They're not ultraviolet or visible light photons anymore. They're not like the ones that came streaming in from the sun. Instead, they're infrared photons. And the infrared photons have a tough time penetrating the atmosphere because of greenhouse gases. Greenhouse gases are very good at scattering those photons. And so rather than those individual little packets of energy leaving the Earth and streaming out back into space, some of them do, but not all of them. Instead, they collide with a molecule of water vapor, or they collide with a molecule of carbon dioxide, or a molecule of methane, and they get scattered. And they get scattered back down towards the surface of the Earth where they stay. And that's why the air, the water, the Earth itself isn't 0 degrees Fahrenheit. It's 57 degrees Fahrenheit. And we're very thankful for that. We need the greenhouse gases to be alive today.
Very, very good point. I remember seeing Bill Gates at one point saying we need to get carbon dioxide basically down to 0. And it's a famous speech because he says, I know that's controversial and it brings in things like death panels and stuff like all this, but that's unrealistic, is it not? Very unrealistic with us here and the way we live, Brendan, right?
Well, it's incredibly unrealistic even in the absence of cars or fossil fuels or any combustion. It's unrealistic in terms of the planet itself because, human beings or animals, they breathe. Yep. And they breathe in oxygen and they breathe out carbon dioxide. And the cycle is very good. We output the carbon dioxide. The trees use the carbon dioxide along with water and sunlight as a byproduct. They spit out oxygen. Okay. And then we breathe the oxygen. It's a beautiful cycle. In fact, it's like mystical. It's insane. It's insane how cycles tend to work here on the Earth, how we've come to be in such a beautifully crafted environment. I understand why religion exists. I honestly do, because this all seems too coincidental to be fact.
I'm one of these dudes that thinks that, this is the best way that we can explain it in our lexicon of language, our understanding. The closest thing that I would put this all down to, like you're saying, these systems they're magical. They truly are. I think we're in some form of simulation. Now, I know there's people out there talk about that, but, the math, the way that these systems all work just perfectly, it just happens to be just right, It suggests to me, some people say creator. I'm good with that. I prefer to call maybe God a programmer, a coder. It's just all too perfect, Brendan,
Yeah, and then there's also, the idea that the reason it's so perfect is not because of some creator, but in fact, the reason we're here is because it's perfect. And there might very well be tons of universes where the conditions aren't perfect and where humans don't exist. And so we are here and we think, wow, this must have been created by someone because it's so perfect. But in fact, we don't realize that the universe made tons and tons of failures. That's the counter argument to what you just said. And it's an interesting one in that.
No, I like that idea as well. I like the way you said that there because, how many do we even have a ballpark figure for the amount of planets that are in existence throughout the universe? Probably a number that I can't even picture or fathom right now.
Yeah.
So there might be some that might just be about right, some that maybe went too far the other way. And like you say, we are here because this is exactly the way it is. It's conducive to life.
Mm-hmm. Yes. So the problem with greenhouse gases, of course, is that when we talk about there being too much carbon in the atmosphere, what we're really talking about, too much carbon dioxide, is that can this greenhouse effect be bad? Like, can we overdo it? If we put too much carbon dioxide, too much methane in the atmosphere, can that process quickly run away? And all of a sudden, all of the energy that's streaming upwards is not escaping into space, but all of it is now being pushed back to the Earth. That's the idea, right? So, Kev, can we agree? Can we find common ground in saying that you think that the way in which we measure temperature is sound, and therefore the fact that we're measuring the temperature of the Earth changing is sound? Can we agree that the temperature of the Earth is changing? It has nothing to do with climate change, nothing to do with carbon, just the fact that we can measure the temperature and that we, acknowledge that it is increasing. Or
Yeah.
can we agree on that?
Oh, absolutely, man. Yeah.
Okay. So the open question, and the one that a lot of people find trouble agreeing on, is whether or not the fact that we're putting methane and carbon dioxide into the atmosphere and water vapor into the atmosphere is actually causing the rate of temperature to increase. And when you understand the process, you come to an interesting conclusion. You come to the conclusion that yes, it must. Like, if you put more carbon dioxide in the air and more of the energy that's being radiated upward is not allowed to escape, but it's being pushed down. I mean, it realistically, it doesn't take a genius to understand that could cause the increase in temperature.
It's absolutely got to be doing something, right? It's got to be changing something.
And this is the thing that people get hung up on, is like, well, what degree? Well, the truth is that to what degree is a really tough thing to answer. And I think that a lot of people who study climate science are really quick to answer that question, like, humans are the direct cause. And yes, humans are undoubtedly contributing. And in my personal scientific viewpoint, we are the direct cause of the problem. But also, I believe that this was a problem that we almost had to have. Like, this is a problem we had to have. This isn't a problem that's like affecting the humans unfairly. This is something that undoubtedly we had to encounter, because without the fossil fuel industry, we would not have progressed to where we are today. Without the use of plastics, we would not have been the people we are today.
So you're really touching on where I land on this, because I'm not a climate change denier. That I think that would be insane, But it's the amount of a role that we ourselves are playing. That's where I've got the problem. That's where I find the grey area. And we see so many politicians so keen to blame man's influence on things, because I think they've got ulterior motives, like we touched on in the first segment of the show. So the climate changing for me is a no-brainer. Always been changing. It will always change. It'll go up, it'll go down. But it's how much of a role we're actually playing in that. So you're really kind of talking my language here in this segment, to be honest.
Yeah, and the thing is, like, you believe, Kev, I think we can agree on this too. There are hundreds of people, thousands probably at this point, thousands of people at the top of the climate science field working on understanding why the climate is changing.
Yeah.
Okay. And those people are working tirelessly to understand what is it that is causing the temperatures to rise, that is causing all of the effects we see, what is causing the Greenland ice sheet to melt, what is causing a record number of wildfires in Alaska, what is causing over 100 wildfires in the Arctic Circle this year. Can you imagine a wildfire in the Arctic Circle? I didn't know there were trees in the Arctic Circle.
It doesn't make sense. I know it's hard to compute in your mind, isn't it?
Yeah. So, there are people trying to understand this all the time. I have faith in that. This is where I come in as a scientist, and I say, I have faith in those people, that they have analyzed many, many, many possible scenarios for why the Earth could be warming, like changes in the sun, like changes in the orbit of the Earth. These are all things that undoubtedly have been checked by numerous people and have been falsified. And so you run into a problem. You say, okay, the only thing that we can think of that seems to make sense, that the evidence supports, is that humans are putting carbon into the atmosphere, carbon dioxide in the atmosphere, methane in the atmosphere, and is causing the temperature to rise. Now, if someone can come up with a different idea, a different mechanism, then I encourage them to. But, I do think that the climate science field feels like they have this one figured out. And Kev, I am like you in a lot of ways. And when someone tells me they have it all figured out, I'm always like, my brain is always like, do you really have it all figured out?
Say that to the audience all the time. If you find somebody that tells you they know exactly what's going on and they've got all the answers, run the other way.
Yes, exactly. And so that's, I always like, wait a minute, do you really have it figured out? But then also you have to realize, like, all the listeners, they have something that they're really good at. Like all the listeners have something that they are damn good at. They have a skill. They have something, a job, a career. They have something that they have done for a long time and that they become really good at. And now imagine what it's like for a climate scientist to try to talk to someone who denies climate change. That would be like you trying to talk to someone about the thing you're really good at and them telling you that you don't know anything. And then you realize, oh, wait a minute. You literally don't know anything. The person that's, the person that's critiquing you legitimately has no experience in the field. And so it makes you angry, I imagine, as someone who studies climate change, when the people critiquing you have literally no basis, no understanding, no place to even start to begin telling you that you're wrong. And so I try to trust the scientific method in this regard. I know that a lot of people don't like to do that. Like, what, trust people? Why would I trust people? How could I trust people? And it's a tough thing. It's a tough thing, but I trust that if the consensus is that the majority of warming we're seeing on the planet is due to carbon and methane emissions from human beings, then we should trust that. And I'll also say this, even if that's not the truth, let's assume it's false. That conclusion is still indicative of a problem. The problem is that we need to stop destroying the planet we live on, right? So even if the conclusion is false, even if the planet really is warming and it has nothing to do with the carbon, that doesn't mean we should continue relying on fossil fuels. I mean, because inevitably fossil fuels are going to cause a problem. They already are causing a problem, in my opinion. But even if you don't believe they are inevitably going to. And so, I say, let's try to have progress, correct the problems. And honestly, Kev, if I'm being serious, we have had progress. We have. We've gotten better at this thing. We've gotten cleaner ways of extracting fossil fuels from the ground. We've gotten better at doing it. There's still a ton of problems.
That's
like
the one good thing about climate change, right? Because it's almost forced us into a change. And it has made us really spend more money, more time researching renewable alternative energy options. So, that's maybe the one good thing out of this whole debate, above and beyond everything else, the fact that we are pursuing different ways of looking at things. And, over here in Europe, I remember a story at one point, and I'm going to struggle to tell you this without laughing, Brendan, because there was like a picture of a field of cows, and they had like these big plastic bags on them, and they were catching the cow farts. Now, Christmas dinner, I love my Brussels sprouts, I love my vegetables, and I make a hell of a smell, right? But I'm not destroying the planet with the methane coming out of me, am I?
You are not. No. See, this is something that I always get in arguments with people about. One of the things that I tend to get, everyone has like that one thing that triggers them, that like, why are you doing that? Why are you talking like that? Why are you being that way? That sort of thing. For me, it's vegans who think they're saving the planet. That's the thing that triggers me. And the reason that's the thing that triggers me is because I see a lot of this like anti, cow farts are killing it's funny. Cows do emit a ton of methane. But they actually do it through their burps more so than their farts. Interesting side note. The burps are like 90% of the methane. The farts are like 10%. But anyway, not the point. The point is there's like 90 million cows in America. 90 million agricultural, cattle in America. Cows output a ton of methane. A lot of it. Like they do. That can't be denied. But when people say I stopped eating meat because I don't like methane production, I always say, but wait a minute. Literally just 1,000 years ago, 2,000 years ago, there was a herd of bison in the continental United States that was in the numbering in the millions, the tens of millions. In fact, the estimates put it at 40 million. We've hunted them essentially to extinction, to the point where the bison herds in the continental United States you can count on one finger or on one hand. You can count the number of bison herds in the continental or in the lower 48. So what does that mean? Well, that means bison also produced a lot of methane, and the universe, the earth, just put them here naturally through evolution. Okay, they were here. And not only do they produce methane, but they produce way more methane than cows do. So you have 40 million bison that were here naturally. You've replaced them with 90 million cows that are agriculturally farmed. The actual methane production in the United States of America, in terms of agriculture, specifically when we're talking about meat raising cows and murdering them and eating them, that the methane production has not really gone up that much. Now, the methane production has gone up due to other things, like fossil fuel production or burning fossil fuels. But the actual this is where the talking heads get us into trouble, because they bring stuff like this up, and then people like you are naturally like, listen, dude, it's don't put cows in bags. The farts, are they really that big a deal? And it breeds like a sense of disbelief, because you're like,
it just looks too ridiculous. It looks like something out of a Monty Python sketch or something.
Yes,
you know what I mean?
Exactly.
It's just bizarre.
It's crazy. And so, I think that you can live a perfectly sustainable life by eating beef, but you should probably not eat like factory farmed meat. But that's not for the sake of the planet necessarily, as so much as it's for the sake of you. You as a human being, and like ethically, it hurts. I had a Dr. Aisha Akhtar on, and she's a expert. She's written books on factory farming and the effects it has on the meat, and the effects it has on human health. And it changed my view on this whole thing. I'm like, since then I've eaten like clean meats only. I don't do the fast food. I try to buy everything as grass fed and
very
pure
hesitant
and local as possible.
to call anything from a fast food joint meat. That's really
but McDonald's 100% beef.
Oh yeah, absolutely. Now we're almost on the break, Brendan. You give people your details. Where's the best place to follow you? Then when we come back after the break, we're going to continue this. I'll ask you another couple of questions on this topic. How maybe the Amazon, what's going on there, affects this. Volcanoes, how do they play into this kind of thing? There's the music. We'll come back on the other side, and we'll get into all of this with Brendan Drachler. Don't go anywhere, folks. We'll be right back. Hour number 2 with astrophysicist Brendan Drachler from Rochester Institute of Technology, all the way over in the USA. And we're having a very open and frank discussion about climate change, climate science. And again, Brendan, I want to thank you, because already I've learned a lot. You've given me a lot to think about. It's very refreshing, to be on a show like this and not just be bashing the mainstream scientists for things that I personally don't know enough about. So thank you for that. Now, before we get back into it, let people know where they can keep up to date with your podcast, all your other details. You go for it, man.
It's available everywhere. Everywhere you can find podcasts, it's on there. If it's not on there, I don't know where you're listening to it. If it's not on your platform of choice, let me know, though. Shoot me an email, and I'll get it on there right away. thestateoftheuniverse.com. You can find us on Twitter. You can find me on Twitter. You can find the show on Twitter. You can find me on Instagram. You can find the show on Instagram. Everywhere. YouTube, you got it. It's everywhere. I think nothing more needs to be said. I have excellent guests on this past month. I had some experts on the Maya, if you're into archaeology and the way in which archaeology gets corrupted, and the way in which the things that maybe that you're taught aren't necessarily the things that actually happen. We talk about the 2012 debacle. We talk about some other cool stuff in the history of the planet in South America. I had a Dr. Sarah Masri on. She's an expert on the moon, the cratering on the moon. In fact, this is an interesting discussion for what we're talking about right now, Kev. Her research showed that over the past 250 million years, the number of asteroids hitting the Earth and the moon increased by a factor of 2 or 3, and may very well have been the reason that we had so many mass extinctions in that period. So I talked to her for an hour and a half. Go listen to it. It's the number one podcast right now, number one episode right now in Ireland,
like
as well
that,
as
dude.
tons of other places. But Ireland's the one where we hit number 1. Other ones were top 5. So
every time I speak to you, man, you're growing all the time, and that really
we're number
pleases
3.
me. Well,
now the show itself is number 3 on Apple Podcasts in the astronomy physics category. So we're doing the damn thing.
Awesome, man. So what 2 shows do I need to bash to get you to number 1? I'm only joking, man.
I'll have to check. I think one of them's Sean Carroll. So
wow.
You'll have to do that.
Sean, I love listening to him. Absolutely fantastic. Yeah. And if you're up there rubbing shoulders with people like that, I'm telling you, I told you, you're set for a big future.
I have a personal connection with Sean Carroll that I'm waiting to use. Like someone I know who knows him well and can get in contact with him very easily, and I'm waiting to use it until the show is a little bit bigger, and then we'll try to get him on. So
or use it, and then hopefully that will propel you to that place you want to be.
So that's a fine line, though, right? You know that being like you don't want to reach out to someone when the show is not quite at that level yet, because you don't want them to say no, that's a waste of my time, right? So it's very strategic the way that you sort of have to plan these things out, and maybe you have a different technique. Maybe you're just the brute force.
No,
and maybe that works.
I used to be kind of in awe of big names like Sean Carroll. There, I'd go, Geordie Rose. We'll not go near him. You know what I find though, Brendan, and it's so obvious. I mean, it makes common sense. They're just humans. They're just normal people like me and you, and it's just an ordinary conversation. They don't see themselves as any more important than anyone else. Well, sometimes they do, but
yes,
I think, give yourself more credit, man. Go for it. Get them on.
Yeah.
And then from there, watch even more coming onto your show. Said it to you when we first done the show. You're absolutely doing good work, and it's only getting better over time. That's why I tell everyone, check out thisstateoftheuniverse.com. It's on my iPhone, but I was honest enough to tell Brendan it's very hard for me to get a chance, a couple of hours, an hour here, hour there, to listen to. I would love to binge all day on Brendan. One day soon, I really will. And the caliber of guests, and this audience in particular, we're a bunch of geeks, as well as conspiracy theorists and pseudoscientists, but they would really, really, I know for a fact they're going to really like your work. They're going to like the information. You cover AI. You cover a whole host of topics that people are thirsty for information on,
Yeah. I just try to be different than the people doing the talking now.
You know what to do, Brendan? Just be the very best version of Brendan Drachler you can be.
That's what's going on. That's how we're doing it. And, science can be so boring sometimes when people communicate it. And hopefully I do a good job of not doing that. Probably sometimes I do, because, how long can you talk about greenhouse gases before someone falls asleep? It's just not an exciting thing sometimes. But, we try to cover it. We try to educate, but also provide some entertainment in the process. And hopefully you guys check out the show. Kev, what more do we have to cover with greenhouse gases?
Well, I was going to ask you, it might be relevant. It might not be. But I often hear people, and I think I've said it myself from time to time, what kind of contributing factor do things like volcanoes play into stuff like this? Do they play into science, into the climate change thing at all,
Of course. Yes. And in fact, they they can either behave as a cooling agent or a warming agent, depending on the type of volcano, right? You can have volcanoes that tend to spew out toxic molecules, like the types of things that can warm the earth over long periods of time. And I had a Yellowstone volcano observatory, the head of the Yellowstone Volcano Observatory, the guy who would be the first person to know if it's going to blow up on my show.
You mean the YouTube experts aren't the first people to know? Oh, no, imagine my surprise that you're not going to get the truth about that on YouTube.
No, this guy, he they go around everywhere in Yellowstone. They analyze seismic activity, and they would know, what if this thing is going to blow up, what's going to go on. But, and they also measure things like this, like how much carbon is being outputted, how much, stuff. And it turns out to be a pretty small percentage of the global carbon. And also, you could have a different scenario. But so I'll answer before moving on. I'm not trying to avoid the question at all.
No, not at all.
Yes, volcanoes could very well cause climate warming by excreting large amounts of greenhouse gases at one time. But most major volcanoes are being monitored well enough that we know that isn't happening. Now, but on to the second thing, that it could cause global cooling. If you have a volcano like a Mount St. Helens type volcano, that is a cone, and it will blow up violently like Yellowstone might do one day, or has done in the past, it will shroud the entire Earth in a covering of dust, and that dust is very, very good at not allowing the sunlight in. And so it causes global cooling instead of global warming.
Well, it's funny you mentioned cooling, because, sorry to cut you off, Brendan, but
no,
I hadn't thought of this, but there are climate scientists out there who say, as opposed to a warming period, we're actually getting close to entering a cooling phase. And they look back at things like the Maunder minimum and they bring that up. And again, I don't know. So could it be we've got this wrong? Are we going to go the other way? Not full ice age or anything, but, a cooling period.
I remember that there was not I remember as in I was alive, but I remember reading in the 70s, I think in the 60s and 70s, there was a lot of fear about global cooling. I don't think there's any evidence to suggest that there's any global cooling happening now. I think, but again, these things are so volatile. If you are like me and you believe that humans are causing a lot of the warming that we observe on the planet, and we've already agreed that the warming that we observe is a real warming, whether or not you agree with the cause is a different story, but the warming is happening. It's happening at a rate that has not been seen, other than a catastrophic event, which you could look around and you could determine that there's no catastrophic events happening. There's no super volcanoes going off. There's no asteroid impacts. There doesn't seem to be anything that could cause a global change in temperature on the scale that we are observing, other than the fact that humans are, blowing greenhouse gases out of their muffler every single day, hundreds of millions of them. So, yeah.
I like how you put that, out the muffler. Very, very well put, sir. Now then, more serious note, the Amazon, these forest fires. Now, I was speaking to my good friend Scotty Lopez the other day, and I've got to the point now where whether it's a hurricane, forest fires, any kind of natural disaster, I've stopped going to social media. And it's not that everything on there is fake. However, there's a tendency for some people to knowingly, or maybe unknowingly, unwittingly, repost images that aren't even to do with the event in question. You get pictures of floods from 10 years ago, and I don't know what's real and what's not anymore. And I'm sure there's a lot of people out there in the same boat. These Amazon fires, this is a controversial one. What's going on there, Brendan? And how does that play in to life on the planet? They say the Amazon, it's like the lungs of the planet, things like that. What's going on there in your opinion?
So I'll say three things. Number one, the photos that a bunch of people share, majority of them are bullshit, right? Number two, the Amazon is the lungs of the planet. Also kind of bullshit. And then what was the third? You asked a third part to that question, I think.
I'm trying to think now.
Well, it doesn't matter. We can talk about the lungs of the planet.
Yeah, well, the fires in the Amazon themselves, I mean...
Oh, right. Right.
What's to be
like these are unprecedented fires. No. They're not unprecedented fires. They're not good. Don't get me wrong. Like, a lot of these fires are slash and burn fires. People are, making room for agriculture, for farming soy, vegans, and meat, non-vegans. We're both in this together. So, they're slashing and burning a lot of land and trying to clear the way. A lot of this, which isn't being reported by the media, of course, because it doesn't fit the narrative, as we talk about all the time, is that a lot of this is already farmland. This isn't old growth forest. This isn't parts of the rainforest that are, still have animals and all this ecosystem that we're devastating. A lot of it is old agricultural sites that are just being cleared again for more growing and raising animals and agriculture. But the lungs of the world, I keep saying this, the Amazon produces 15% of the global oxygen. The thing is, Kev, the Amazon is essentially self-sufficient, as is really any area on the planet. Most areas, like we were talking about the cycle earlier, where we breathe in oxygen, we output carbon dioxide, the trees use the carbon dioxide, water, sun, to photosynthesize, and in the process they output oxygen. That process tends to work perfectly. Okay, there tends to not be excess. So any oxygen that the rainforest, the Amazon rainforest creates, is in turn used by the inhabitants of the region, by the animals there, by the humans there. It is used. It is a perfect system. But what people don't talk about enough is that we have an abundance of oxygen on our planet, a real abundance, like way more than could be produced by plants. In fact, if we chopped down every tree on the entire planet and we didn't allow any photosynthesis to happen and we didn't allow any oxygen production to happen, there would still be enough oxygen for all of us to breathe here on this planet for hundreds of years. And the reason is an interesting one, and it has everything to do with phytoplankton. If you know what phytoplankton are, they're these little, I don't know, bugs, if you will. This is probably a technical biological term. Maybe there's a biologist listening who's upset with that. But these little creatures that live in the ocean, the upper layers of the ocean, and they photosynthesize. I don't know how to say words today. They photosynthesize. They breathe. They take in the carbon dioxide. They take in the water, which is very easy for them because they live in it. They take in the sunlight, so they live in the upper layers of the ocean because that's where the sunlight actually reaches. They produce oxygen. The oxygen, leaves, goes away. Well, what happens, Kev? I want you to imagine you're the only human on the planet, Kev. Okay, just you, and there's only 2 phytoplankton on the whole planet, and you are in perfect harmony with these things. They are producing oxygen, or they're outputting oxygen. You are breathing in the oxygen. You're outputting carbon dioxide, and you're in perfect harmony. All right. Now, I want you to imagine that one of these phytoplankton, they take in the carbon dioxide. All right. They output the oxygen. Now, there's some oxygen in the air. Kev is going to breathe it in. He breathes it in. But in the process of you breathing it in, Kev, imagine that one of these plankton dies.
Uh-oh.
And it dies, and it sinks to the bottom of the ocean, and it gets covered up with soot, and it sits down there. What happens now? Well, what happens is there's more oxygen on the planet now than you are actually using, because 2 phytoplankton created oxygen, but you're only one person, and you breathe in. And then do you understand how there's excess oxygen in the process? Okay, this happens over the course of billions of years on our planet. And the atmosphere has become very oxidized. The atmosphere is like 20% oxygen. Most people don't know it's mostly nitrogen, but it's 20% oxygen, and that's because of billions of years of this cycle. And that's actually the exact same cycle that creates the fossil fuels. Because the phytoplankton die and they sink to the bottom of the ocean and they get covered up and they get compressed and they get heated up and they turn into fuel, and then we mine for it. But they turn into natural gas, I should say, not fuel. We use it as fuel, but they produce natural gas. They produce hydrocarbons, and then we burn them for energy. But this very process has happened over billions of years, created tons of extra oxygen that's floating around in the sky that we can breathe just perfectly, even without the Amazon. Does that mean we should ignore the Amazon? No. The deforestation happening in the Amazon is a separate problem, and it's a problem that's been happening for decades, and it's a problem that we haven't solved for decades. I hope that this, instance brings some eyes to it so it can actually get fixed, but, it hasn't been fixed. And in fact, the amount of deforestation happening right now isn't even the highest it's ever been. The amount of wildfires in the Amazon right now are not the highest they've ever been. They were literally higher in the year 2010. 9 years ago, the Amazon wildfires were worse than they are today. This isn't a climate change problem. This is like a social media engineering problem.
Absolutely. And we were even saying, you had highlighted as well, I'd read reports about even the mainstream. I don't trust the mainstream at the best of times, but usually I don't expect them to be reposting or showing images that are of different events. But even they've been getting it wrong on this. And I heard one of the Brazilian government, I think he was the Minister of the Environment, and he was explaining that even after all this time, after the Spanish went over to South America and everything that went on there, only 18% of the Amazon rainforest, and we can only take what this guy says at face value, I could be wrong, Brendan, but he says only 18% has really been kind of cut down, used for farming, etc., etc., and the majority of the Amazon is exactly the same way as it always has been. It's untouched and it's still going strong, So
yeah. It's true, but think of it this way: 18%. That's essentially 20%. That's essentially 1/5. Imagine that every paycheck you got, Kev, they were like, I'm going to take 1/5 of that, off the top. They're like, kind of like taxes.
Yeah, that's what my government does anyway.
Yeah, right. Right. And that's not very awesome. Imagine, everything you do, someone takes 20% of it. So yeah,
it's not
20%.
But, if you were to look at the media from the last 3-4 weeks, you would be forgiving people for thinking that maybe we're down to the last kind of hectare of Amazon forest.
Exactly. Yeah.
Yeah, absolutely.
No, it's an interesting point. I hope that something good comes of it. I hope that people say, okay, we should be more conservative in the way that we treat the planet. We should be conservationists. We should try to, the fact that we're missing 20% of it is even a big deal in my mind, because that's such a wealth of biodiversity. That's the most
Yeah.
biodiverse place in the world. I mean, if you ever watch like Planet Earth they're in the Amazon, you are in awe. You're like, oh my God, this is like, how can this animal, like some of the birds that you see, um, some of them you're like, how does this even live on the same planet as me? Like, this seems like a movie. This seems like someone made shit up.
Yeah.
And it's a shame to lose it.
Oh, absolutely is.
Frankly.
Now, one last point about the rainforest, and this is something that I don't hold to be true, but I've seen people saying it. It's a rainforest, Kev. There's that canopy of water and everything else. How the hell can a rainforest be on fire? There's forest fires in the rainforest like every year. Can you explain to people that that's absolutely fake news, that you can't have fires in a rainforest?
Yeah, well, it's hard to have fires in the rainforest, right? For obvious reasons, but it's not hard to have them when humans are setting them, which in large part is what's happening in the Amazon. You have human beings who are slashing and burning to make room for farmland. So yeah, you can make anything burn if you try hard enough. I mean, you can find videos online of people's tap water being caught on fire. So you know, if you work hard, if you dump enough chemicals, if you dump enough gas, and you light enough matches, eventually you can get a fire pretty much anywhere.
So, Brendan, to wrap up the whole climate science, climate change, and again, I thank you for taking the time out to look into this, put some notes together, talk to the audience about this. Is it that pressing that we really need to be thinking about going interplanetary within the next 100 years? Or are some of the fears that are being hyped up by the media, by the politicians, to the point where, people just calm down? It's not as bad as we're being told, and there's not any pressing need for us to go interplanetary just yet to maintain and to go forward as a human species, right?
Yeah, well, we definitely don't need to go interplanetary. It's when you mentioned simulation earlier, Kev, I couldn't help but think of this. This is interesting to me. Imagine this whole like climate science thing. To me, honestly, it seems like simulation, because imagine you wanted to make a movie and you want to make a really good movie, and you were like, all right, we're going to take these people and we're going to put them on a planet, in the middle of nowhere. We're going to make sure that they can't travel anywhere else. We're not going to give them the technology to travel. We know it's going to take thousands of years to develop the technology to travel anywhere. So we're just going to sit them on this rock in the middle of nowhere in a solar system. But let's add some more features. You're the creator of the movie. You're like, let's put Mars like next to Earth, because Mars is like this desolate wasteland, and it'll like tease them because they know that it's viable and you could feasibly go there, but you can't live there. It'll be too cold. There's not enough of an atmosphere. And we'll put that there, and it'll be kind of tease them. And then what we'll do is we'll put another planet right next door, and it'll be Venus. And we'll put Venus next door, and what we'll do is we'll make Venus have a runaway greenhouse effect. We'll make it so that Venus is 800 degrees Fahrenheit because its atmosphere is 96% carbon dioxide, and it just keeps heating up because all of the sunlight that falls on it can't escape. So it's like an oven that just keeps heating up with the door closed, and no heat is getting out. And then what we'll do is we'll give these people fossil fuels, and we'll allow them to create their own greenhouse effect, their own runaway greenhouse effect on their planet, and we'll see if they can band together to fix it. And in the meantime, we'll tease them with Mars next door, and we'll show them the outcome with Venus next door, and we'll see if they can figure it out and work together. It seems like a simulation to me.
Oh, I'm telling you, dude. I've got a computer game called No Man's Sky. I know,
Yeah.
a grown man playing a computer game, right? But, I'm not saying definitively, how could I, Brendan, that we're in a simulation? Because, life's real. The universe, very real, right? Doesn't take away from that. However, you've got this game, and out of 140 lines of code with generative procedural networks, now I'm struggling with words, it's able to create a universe where there's 18 quintillion planets. And I was looking over this with a friend last night to visit every single planet in this simulated universe, which is on a classical computer. So it's not exactly even the best of computers. It would take 585 billion years if you were able to visit every planet one a second. That's how big this game is. Now, some of the math that they've got coded into this, every planet you go to, there's diverse biology, there's unique kind of chemistry and things. It just makes me wonder, dude, that's all. It just makes me wonder if we can do that on a classical computer and then we look at this majestic universe that we're in. Imagine technology out with what we can comprehend. I wonder if that's what put all of this into motion. I know it's a very out there kind of thought. A lot of scientists talk about this. It's a harmless kind of conversation,
Yeah,
but
it's
weird,
it's
right?
an interesting conversation, but like I don't know. For me, it just pushes the paradox further back because okay, what if people are simulating us? Who's simulating them? You
Yeah,
know?
I mean, we're on the verge now. I mean, with that game, I mean, give it 10 years, once maybe a quantum mainframe or something like that, we may be able to create a simulation of the universe which is quite indistinguishable from reality, right? And then that opens a can of worms because if we can create that, then who's to say we're not in one of those simulations ourselves, you know?
Yes, of course, but again, like who's simulating us?
Yeah,
Who's
exactly.
who's simulating them?
It's a
And are
YouTube
they
channel. It's
are
a
they in the
YouTube
real
channel, dude.
universe?
It's somebody on a YouTube channel in another dimension somewhere. They're having a laugh with all of us, man. That's what it is.
Yeah.
So
Well, if
listen,
they are, whoever you are out there simulating me, I would like a couple more 5-star reviews on Apple Podcasts. So hit me up with that.
I'll give you one right after the show, okay? But before we
Okay.
will come back after the break, when we'll get you into, your specific kind of field, space, stuff like that. Some of the guests you've had on, you mentioned the girl or the scientist about the moon. Who else have you had on lately, man? Whet our appetites for your podcast, Brendan.
Well, I'll tell you later this month. I have our friend Brian Keating coming on.
So have I.
have
Yeah, I've got Brian. It's the anniversary of his book.
Yep.
Yeah.
Yep. So he'll be coming on. I have some Nobel laureates lined up for the future.
Oh, look at this. He just nonchalantly drops it in there,
Yep.
Some Nobel laureate.
Lately, I've had exoplanet experts. I've had experts on the moon, experts in history, experts in AI. Go check out the show. Experts in fast radio bursts. The whole thing. So
Please check it out, folks. You get it on iTunes in the apps. Go to the kind of podcast section. You'll find Brendan in there. One of the top 3 science podcasts in the world, Brendan, right? Like top 3 in the world. Is that what we're talking?
top 3 astronomy physics. Yep. Apple did this thing recently where they sectioned off, like it's not just a science category now. It's like different.
Oh, they've made it more specific.
Like even more specific. And I got classified as physics astronomy. So we also rank high in the other categories. We like in the science category.
We'll be right back, folks.
Category.
We'll be right back with Brendan Drachler. Don't go anywhere. One segment to go, and we're going off planet. Welcome back, ladies and gentlemen. You're listening to the Kev Baker Show. Final segment already with my good friend Brendan Drachler from the Rochester Institute of Technology. He's an astrophysicist. We've been talking about climate science. Really enjoyed this first 3 quarters of the show. Can't thank Brendan enough again. But now we're going to get to where he really does excel and know his stuff. He's an astrophysicist. So let's get into that kind of stuff. Let's go to space. Let's start talking about the kind of things that we often talk about here on the show. Again, though, from a science perspective. And I'm looking at the list of topics you gave me. And this is something I brought up briefly. And we had a bit of a laugh and a joke with it on a show we call Freaky Friday here. And it's China. They've got rovers on the far side of the moon. And they have come across some interesting substance. They call it some goo, some mysterious goo.
Yeah.
What the heck is going on, man?
I know as much as you. They say they found it. They released an image, I think, of the crater that they found it in. Like it's just a tiny impact crater, but they didn't show an image of it. They didn't show what it looks like. If it's called a goo, like I don't even know what it could be. A goo. It's the weirdest possible thing to describe like something you found as. because Ghostbusters is like what I think of. I don't know.
But Slimer, there's a thing called black goo. I don't know if you've ever checked into the black goo conspiracy. If you haven't, please do. It's a rabbit hole.
God.
Oh, it's a rabbit
Because
hole.
now I guarantee these people are thinking that the black goo
Of
is on
course
the
they
moon.
are. Of course they are. It's YouTube land. It's alternative media.
What is the black goo?
It's meant to be an ancient, sentient alien substance that has escaped into the wild. It kind of they discovered it during the Falklands War. It was taken back to the UK. It shapeshifts. It's able to do a whole heap of things, man. I kind of
Well,
I challenged one of the scientists that really covers this to show me the black goo. To which he said, "I'll never come on your show." So I don't know what's going on, man. But could it be? Could it be?
I would
then?
bet now these
go.
black goo people can't be can't not believe in the moon landing. So now they have to pick one or the other because the black goo had to get to the moon somehow, and maybe it hitched a ride in Apollo.
Now, personally, I'm laughing about the black goo, but I find it a fascinating topic. And me being a pseudoscientist, I often get into the black goo. You see it depicted in movies all of the time, which adds to the woo factor. Not the wow factor, the woo factor. Not to be mistaken with the goo factor either. But let me ask you, we had this Israeli mission lately that was unsuccessful. Something went wrong. Could it be, and I'm stretching things here, dude, could it be anything? Like some kind of debris, something that came out of the Israeli satellite? Was it like Slimer's cousin? I don't know, dude. What's happening?
Your guess is as good as mine. I can't wait until they release images, because I don't know what black goo. Here's the thing: like when you think of goo, you think of like liquid, right?
Mm-hmm.
Like typically goo is like slimy and liquefied, and there's some water in there, and the problem with the moon is it's so damn cold, so you're not gonna have anything liquefied, at least not anything that we would think to find on the moon. So,
did Buzz Aldrin leave a number 2 up there? Is that what he
that's
done?
possible.
Who knows, dude? Who knows?
Yeah.
But maybe in the Beijing kind of space command center, whatever they've got over there, maybe they've heard the black goo stories and they thought, this will spark a bajillion conspiracies.
Yeah. It's interesting to me that like they were so forthright in just publicizing it.
Yeah.
It's like that. It's specifically coming from China, which is notoriously a pretty private group. The Chinese spaceflight community is a really closed group. If there's one group to not trust, it's not NASA. It's those damn people, because they don't talk much about the goings on in their missions. But they're very successful.
I was going to say
they're very
that,
good at doing what they do.
Yeah, they've got their Chang'e missions, and I think there's, the next stage of that will be returning samples back to Earth, I believe. Maybe they'll bring
take the black goo.
Maybe they'll take the goo back, exactly. So whether there's goo, well, to goo or not to goo, that's the question. Are they going to build bases on the moon? That was another one of your talking points here. A bid for the first moon base. What's going on, man?
Yeah, so Newt Gingrich is trying to pioneer an effort, trying to convince the White House to allocate $2 billion as an award to the first organization that can get to the moon with their own private vehicles and build a base on the moon. And apparently that this isn't just some chirping. But this is potentially something that NASA will actually allocate funds for trying to pay the first organization that gets to the moon and builds a base, builds a camp, builds a place where a human could live and stay. Now, there probably won't be many people taking them up on the offer, because $2 billion is not a lot for achieving that monumental of a feat. But it's something maybe we could see in the next 10 years or 20 years. You'd mentioned the Israeli satellite. In fact, the reason the Israeli satellite even got to the moon is for this exact reason. Is that right? The Google, what's that called? The Google X Prize or something?
Yeah, X Prize. That's right. Yeah.
Yeah. So they were awarding $20 million to whatever private organization could get a satellite on the moon. or orbiting the moon. And no, it was landing on the moon, and they failed because they didn't achieve it in time. Google had set a time limit, and no one had gotten there, but they had pretty much the mission completed, so they just went ahead and shipped it off anyway, with no reward other than getting a plaque from Google that said, "Here, you won the prize, but didn't get any money." So,
So what's the payoff then for countries to get to the moon? We hear about helium-3. That's bandied about a lot, something on the moon. Is there any other resources there that makes it worthwhile actually, setting up camp, setting up colony? Because I would imagine that it's going to come down to finances. Can we make profit out of it in the end of the day? Money drives everything, right? Unfortunately.
it does. It does. And when people ask about the payoff of spaceflight all the time, yes, there is the idea of potentially using things like helium-3 or mining asteroids.
What do we even use helium-3 for? I mean, why is this such a thing?
I don't know much about the reason that people bring up helium-3, though I will say I've heard reputable people talk about it before. And so it's not just like I don't know if it's a conspiracy thingy or if it's legitimate, but I'm pretty sure it's legitimate. There's actual uses for helium-3. What those are?
We need Warm Flash on here. Warm Flash would sort all of this out.
He would, yeah.
He's definitely the lunar expert, man. But Brendan, what else is going on in space then, dude? Or what kind of things are you working on? How's the simulation going? Anything piquing your interest with news about exoplanets? Anything like that going on right now at all?
The James Webb is finished.
Okay, and this is the next big telescopic jump, right?
Finished, yep, and it will be launched next year, I believe. I had the James Webb coordinator, maybe was her title, on the show, Natalie Willett, and she was talking to us just last month, and just yesterday, I think, it was announced that the James Webb is officially ready to be packaged away and launched. That's exciting.
Well, it's exciting, but it's also a perilous time as well.
Because, it's so scary.
Because, I mean, explain to the audience then, because they may not know why, like, we kind of say, right, this is going to be pretty perilous. They're going to be sitting on the edge of their seats. They're going to be looking through the cracks in their fingers. Mm-hmm. What happens with the James Webb? Explain to people what happens, man.
If you look up a picture of the James Webb people, I had the honor of
I'll bring that up just now, yeah.
I had the honor of seeing it in person a few years ago, but if you look at it, it's I'll wait, Kev, until you pull it up.
Yeah, we can get it here. Telescope. There we go. Images. Boom.
Yeah. So you see this thing is absolutely massive. Okay. Now, what you see there is you see the primary mirror, and what you actually see is that those mirrors are like segmented. There's like little sections on the mirror. It's not just one big mirror. You can see they're like little hexagons. And the reason is that whole thing has to fold up into a tiny little capsule that can be shipped off to space, because you can't launch something that big and in that geometry. That thing would get shredded to bits if you tried launching it like that.
Where does this sit? I mean, is this one of the Lagrange points, as they call it?
Yes. So
you like that? You like that, Brendan? I've been doing my homework. See?
Yeah, once it gets up into space, it's going to head off. It's not going to orbit the Earth like the typical telescopes, which is what makes it so scary. Because if it fails, it fails. There's no saving it. But it has to unfold. So it's this little tiny packed up thing. Kev, you could look up a video of James Webb Space Telescope unfolding, and there's some great animations about how exactly it will be done. But this thing will head off to the L2 point, the Lagrange 2 point, which is essentially a point in space where the gravity of all of the planets of the Earth Sun system cancels each other out. It's like a little parking spot in space, and you could put stuff there, and you could be sure that it's going to be stable, it's going to be safe, and it's going to hang out. Oh, here you have this video up, so you see it launches, and it's this little thing. It folds up, so it expands. The sun shield comes out, and the sun shield will be used to collect energy from the sun, and those will open up into giant shields here in a moment, and then the mirror itself will have to assimilate itself.
I'm watching this, and I mean, there's a simulation, and even I'm thinking something's bound to go wrong here. There's too many moving parts and things.
Yes,
something's going wrong.
You know what's even crazier is, this will be happening while it's whipping through space at tens of thousands of miles per hour. on its way to the L2 point, and where it will park and eventually begin recording, taking images, taking data, observing, and
So
it's scary.
what did they hope? I mean, as opposed to the Hubble, what's the big leap forward from the Hubble?
So one of the big leaps is this is an infrared telescope,
Okay.
as opposed to an optical telescope. So what that means is we'll be able to see way further back. We'll be able to see the low energy photons way further back in the universe. We'll be able to see galaxies way further back in the universe, as far away as possible. And of course, in space, far away means further back, younger.
We've
So
seen
we'll be able to,
the Hubble field. Are we talking something even more magnificent than that?
yes, yes, of course. Now the pictures won't look as nice because they're not visible light photos, but we will learn more from them. Also, another thing that might excite you, Kev, is direct imaging of exoplanets.
Oh, here we go,
We
dude.
might, for the first time, be able to get direct images of some exoplanets and be able to discern what their atmospheres are made of, and these sorts of interesting, important details that we haven't had yet.
And of course, if
It's
we can start to look at the atmosphere, does that mean we can start to narrow down the kind of places where we may find life as we know it?
Yes. And then we can also tell aliens whether or not they have too much carbon in their atmosphere and their planet is undergoing global warming.
Whether
So
there's
that's a
cows
positive.
farting? Too many
Yes,
cows
of
down there.
course.
Get the bags on
Yes.
the cows. No, this is
Yeah,
an
we'll be able to
exciting
tell whether.
time.
Yeah.
And I mean, I can imagine somebody like yourself, you're just embarking on this on your career right now. I can't think maybe of a more exciting time to be you, because the technology we've got, you know, surely this is where we're going to take our next big giant leaps. People like you, scientists that are really on the cutting edge of things right now. Scientists maybe 20 years ago would probably love to have some of the tools, some of the equipment that people like yourself are going to be able to utilize to expand our knowledge on the universe, man. I'm excited for you just thinking about it.
Yeah, it's a great time to be in the field. And if there's anyone listening who's young and you're interested in this stuff, pursue it. Reach out to me even. And we can see if we can get any opportunities set up for interested people. One of the things that, I'd like to get involved with more is outreach for younger people, trying to get younger people involved in this field. My audience is like, the typical podcasting demographic, 18, 36, males, females, but very few like young, aspiring kids. And part of that is my own fault because I tend to have explicit shows because I think that's the best way to reach people if you want to not seem like a robot.
Do you think maybe the danger is, and you had an AI expert on who had changed from astrophysics, I believe, into like big data, things like that.
Mm-hmm.
Do you think more budding scientists are going to follow the paycheck? They're going to go into machine learning. They're going to go
for
into,
sure.
Yeah, do you think that's going to?
We're already seeing that, and that's not a problem. That's a problem that only can be fixed by the university system in the United States in particular, because they're not willing to pay people well. And they're not willing to hire a lot of people. So what you end up having is you have like a few people who are working insane amount of hours, not being able to see their family, not being able to support their family because they're simply not making the type of money that they should be for the level of attainment that they're at. I mean, even me personally, Kev, I'm probably going to go into an industry position in a few years.
Don't lie. You're going to NASA. You're going to be at NASA. just to trigger people, right?
Yes. Yeah, of course. Look, I already got the right there.
It is.
NASA.
Yeah.
But I'll probably do the same.
What about SpaceX? Do you not fancy maybe SpaceX, somewhere like that, man?
Yeah, I know some people that have worked at SpaceX and Tesla, and they tell me it is a terrible work environment in terms of what's expected of you. Yeah, because, those companies, they're working off subsidies. Mm-hmm. They're working a lot of subsidies. So they pay you, but they expect you to work. And when I say work, I mean, sleep in the office some days if you have to.
Well, I've even heard that about Musk himself. At the Tesla factory, he does like 17-hour days, keeps on the office floor and back up and at it again.
Yeah, the problem is like people shouldn't do that It's not even that they shouldn't be expected to do it. It's that they shouldn't do it.
Well, I'd imagine you can't give your best productive kind of self if you're fatigued, you know?
That's the problem. You have to have time to do the things you want to do, to spend time with the family, to go out and enjoy the outdoors and just enjoy your life. I would never tell anyone to do the 90 hours a week unless it's something you love, because there's a reason Elon does it. He does it because he gets a mighty paycheck at the end of the day, and it's something that he really is passionate about and he loves doing. But being a cog in the wheel and being expected to work at that same level of attainment is, for me, not worth it. I would definitely not do that.
No.
I'd be the type of person to start I have no problem doing the science for 50 hours a week, 60 hours a week, doing the podcast for 40 hours a week or whatever, because I enjoy it all. But it's not attainable if you don't like it.
Exactly. Now, you mentioned to me before, is it Green Bank Telescope or is it Green Valley? Green Bank?
Green Bank.
You want me to share with you a little conspiracy that's going around out there on the internet right now? And I'm laughing, okay? It's not one that I personally kind of put out there. I love Alex Jones. Love him or hate him, but...
You have your finger on the pulse of all the conspiracies, Kev.
I'll tell you after the show. I can't really let you in on air how I do that, but, my Russian handlers will probably shoot me. But no, Alex Jones, okay? I love the guy. Don't agree with a lot of the stuff he says. However, I nearly choked on my coffee recently because, as you know, I'd never heard of Green Bank Telescope. And I was fascinated when you were telling me, that people in the area, that they can't even have microwave ovens, and it's this quiet zone because it affects the array, right? And he's come up with this thing now that actually it's not really all to do with the telescope. It's because all of these billionaires, they're trying to escape 5G, and they want these places on the planet like Green Bank Telescope. The telescope, it's just a red herring. That's just an excuse for making this an electromagnetic free zone so that these elites can live there, their DNA won't be harmed. And could you please put that kind of crap to bed for me, man?
Well, I mean, the radio quiet zone has been around since the 60s.
So
telescopes have been at Green Bank since the 60s.
So what you're saying is, Jonesy, because I know Jonesy listens to this show, he must do, right? Because this is a better show. I'm only joking. But he's heard about Green Bank from you, and he's thought, how can I spin this into a Jonesy-type story? And he's thought, I've got it. I won't tell people this has been going on for decades. I'll say this is something new, and this is where the elites are going to go to escape the 5G, right?
Yeah, I that's a silly one. See, that's one of the ones that you can just kind of use logic to.
But people bought it. People will be going, "Oh, those pesky elites! I knew they were doing something, man."
Yes, of course. I just look, like, Google search one thing. That's all. Like, Google, if you go on the Wikipedia page for Green Bank, you can, I think, gather enough information to.
But Google's part of the conspiracy. Nonsense. Come on, Jonesy tells you Google's part of this conspiracy. Dude, it's not. It's going to tell you what you want to hear. Do you know what I mean?
That's fair. Yeah, that's fair. I mean, I went to Green Bank. I've met people that worked there since the 70s, the 80s. Maybe those people were all government plans.
Yeah, they're all in it. They're all crisis actors, man. Come on, we know that.
Yes. In fact, I'll probably be going back maybe next year. So I'll look around and I'll make sure nothing fishy is going on.
Drachler, you're getting paid by NASA. Yeah. I don't believe a word you're saying.
I'll see if I can find all the bunkers and 5G safe spaces.
See, this is why I love hanging out with you, dude. We can have fun as well as put out really good information for people, and I think that helps. I really do think it helps. But before I let you go, right, let me throw you this. Right, Elon Musk, some billionaire, NASA, whoever it is, they say, Brendan, we love what you're doing. We love the way you think about things. We want to give you a blank check. You've got a blank check to do with whatever project you want to do in your field. What would you do, Brendan? What would really light your fires? What would really be your passion? If you had endless funds to do it, what would you work on?
It's an excellent question. What would I work on? Geez, I'm not even sure I have an answer for you. Because I think that, well, let's see. I would certainly get 17 more people to help work on the stuff I'm working on. Because all computational astrophysics, which is what I do, suffer from a people problem. There's just not enough money to pay enough people to solve the problems. Unfortunately, one person tinkering around on a computer doesn't solve the problems you want to solve. So I would do that. I honestly, Kev, all of the changes I would make would be like changes that would attack science from a different perspective. It wouldn't be like, man, I want to fund this project. It would be like, how do I get more people involved in this? Like, what programs how do I make education better in the United States? That's the worst answer that I'm sure you don't want to hear, but that's what I would do. Is I'd be like, man, and also I would write myself a check for lots of money, and
There's
then I
no
would
bad
retire.
answer, dude. No bad answer. You know, I think it's a mark of the man you are that you're thinking longer term and about the youth. I think
Yeah,
that's as good as
because
answer as
there's
anything.
geniuses sitting out there in the in the middle of Alabama in some shitty school district that doesn't provide them any opportunity. And one of my ideals in this field while I'm here is to try to give those people opportunities, because America's a microcosm. Of course, you have billions of people in the world that don't have access to this thing that we're doing. And there's probably an Einstein sitting somewhere in the slums in a city in India or something, or Egypt, or even America. There's an incredibly smart person out there, and man, that's probably what I would use the funds to do is just try to improve the education in the country, and then those geniuses can decide to solve the problems that they want to solve. But one of the things I would really like to do is I would like to pour money into. No, I wouldn't even like to do that. There's so many pros and cons to all of this, Kev. This is a real tough question. I'm in an ethical dilemma now. I'm thinking particle accelerators. I'm thinking dark matter detectors. Then I'm thinking, wait, why put money into dark matter? Because is dark matter even a legitimate thing? I'm starting to have my doubts and all of this other stuff.
Oh, now are you?
Well, not doubts like there's not dark matter, but doubts like, let's start formulating some new ideas here, people, because we haven't been able to detect anything yet. And we continue to pour money into the field, and we continue to build new detectors, and we continue to not find the things we predict that we should find. And when I say we predict, I mean not even like the field itself. I mean the predictions being made are not necessarily being made by, like, the whole field isn't in agreement that this is the thing we should find. It's just some people think we should find this, and some people think we should find that. And here we sit 30 years, 40 years later, finding nothing. Man, I think if there's anything to be skeptical about in the world of astronomy and physics, it's the existence of dark matter. Not that it doesn't exist, but man, we got to get some new ideas here. We got to be creative. So maybe I would pour money into that.
Dude, we've always done good shows. I don't know, but this one, it's been one of our better ones, and I thank you for that, Brendan. Thank you for your time once every month. I hope we can continue to do this. Any big guests coming up in the near future on your own show that people can check out? And one last time, let people know where to check out the podcast.
Go to thestateoftheuniverse.com. If you want to know about new guests, I'll say this. Sign up for the newsletter on the website. I just rolled out these new email campaigns. I update you guys on shows coming up. Every time I have an author come on the show, or an expert in something, I like to give away their production. So I have Brian Keating come on. We give away a few copies of his books to listeners. I have David Warmflash come on. We give away a few copies of his books to listeners, and we try to give back to the people who support the show. So sign up for the newsletter and win some. If you're into science, we give away a ton of stuff to try to grow. So yeah,
we are out of time. Yeah, we're out of time yet again. Check out the stateoftheuniverse.com.
Yes, do.
You can get it over on iTunes. He's all over the internet, folks. Just Google Brendan Drachler, the State of the Universe. I've had a blast. I hope you've all had a blast out there. Hope we've all given you something to think about. Re-listen to this show. It's not the type of show you're going to hear in alternative media very often. So until next time, wherever you are, make it TFR and dinny touch that dial.